Hey people, today we'll be solving our problem of the day, and the name of the question is rotate by 90 degree. So let's see what we have. Here's a question, and we have given a matrix, a square matrix. The task is to rotate it by 90 degree in clockwise direction without using any extra space. So in the question, we will be having a square matrix. So by square matrix, we mean that the number of rows and the number of columns will be equal. It will be a n into n matrix, and we have to rotate it by 90 degrees in clockwise direction. So we will be rotating our matrix by 90 degree in clockwise direction. Let's see with an example. So here's our example. So our example is something like this: 1, 2, 3, 4, 5, 6, and 7, 8, 9. So by rotating this by 90 degree, we will be obtaining this 741, 852, 963. So let's see how it is working. Here we have the similar example, and we have rotated it by 90 degree. So by rotating our matrix by 90 degree, our first row will be moving to to the last column, and our second row will be moving to second last column, like 4, 5, 6, and 4, 5, 6 here, and our third row will be moving to third last column. After doing this, we can say our matrix is rotated by 90 degree as it is in clockwise direction. So this is going in like this way, it is going in this way, and it is going in this way. So our first row is appearing at the last column, and second row is appearing at the second last column, and the third row is appearing at the third last column. If there will be like one more fourth row, it would have been appearing at the fourth last column. To solve this problem, one thing we can do is we can create a new matrix, and we will be storing all the elements at their desired locations, at the desired indices. Like here we have 7, we will be storing 7 at 0, 0, and 4, 4 at 0, 1. But by doing that, we will be creating a new matrix, and by creating a new matrix, we will be using some extra space, and it will be O of n square, which is equal to our size of the matrix. But in the question, it clearly states that we have to perform a task without using any extra space. So we will be performing some operations on our matrix itself so that our matrix becomes rotated. So we will be finding some patterns with the help of which we will be performing some operations on a matrix, and by performing those operations, our matrix will getting rotated. So let's take a bigger example, and let's see what we can do. So here we have a 4 into 4 matrix, 1, 2, 3, 4 up to 16. We have its rotated matrix as well. So here we can notice one thing: our first column is the first row, but it is in reversed order, right? Here our first column is the first row, but it is in reversed order, as it was 1, 5, 9, 13, and it is similar from the back side: 1, 5, 9, 13. And our our second column is the second row, but similarly in the reversed order. And our third row is the third column, but the third row is in the reversed order. And our fourth column is our fourth row, but similarly in the reversed order. What we can do, if we somehow able to find the transpose of this matrix, then it will become easy. So now what is the transpose of a matrix? The transpose of a matrix, our columns becomes the rows, and the rows becomes the columns, right? So transpose of this matrix will look something like this. It will be 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15, 16. If we find the transpose of this given matrix, it will look something like this. And if we somehow obtains the transpose of the matrix, what we have to do, we have to just reverse all the rows so that it will become equal to the 90 degree rotated matrix, right? So if we reverse this row, it will become 13, 9, 5, 1. And if we reverse this second row, it will become 14, 10, 6, 2. And if we reverse this third row, it will become 3, 7, 11, 15. And similarly for the last row, it will become 16, 12, 8, 4, right? So what we have to do, now we know, firstly we have to find the transpose of the matrix, transpose, and we have to reverse each row. We have to reverse row. Let's see how can we find the transpose of the matrix. Here we have our original matrix, and here I have taken its transpose. So in the transpose, R1 2 3 4 is here, 5 6 7 8 is here, and all the third row is the third column, and the fourth row is the fourth column. So to find the transpose, here we have 2 and 5, and in the transpose here we have 5 and 2, and here for 3 and 7, sorry, 3 and 9, here we have 9 and 3. For 7 and 10, their place is 10 and 7. Now what is the pattern here? Here all the elements are swapped with their opposite elements, right? So it was, what was the index of 2 initially? It was 0 1, and now what is the index of 2? It is 1 0. What was the index of 5? It is 1 0, and its new index is 0 1. Let's see about 13 and 4. What was the initial index of 13? Initial index of 13 was 3 0, and its new index is 0 3, and initial index of 4 was 0 3, and its new index is 3 0. So what we are doing in finding the transpose, we are just replacing I and j column with j and I, right? We have just replacing the column and rows with rows and columns. Here if we have a look to find the matrix, what we have to do, all we have to do is we have to shift this upper right with this lower left, right? If this 2 3 4, here we have this 2 3 4, and here we have 7 8 12, and here it is the 7 8 12. So we are just shifting this right part with this left part. To do this, we will be performing swapping. We can perform swapping of I and j with j and I. For the first index, how we will be doing this? We will be doing this for all the elements. For 2 3 and 4, we will be doing it for the, like we say, 0, and for 0 we will be doing it from 1 to 3, and for the I equals to 1, for the first index we will be doing it for 2 and 3, 2 to 3, and for the second index we will be doing it for only 3, and as for the last index, we need to do nothing as it will be already swapped. After finding the transpose, what we will be doing, we will be reversing each row of the matrix, and after reversing each row, we will be having a rotated matrix. So let's jump to the code. So here we have the code. So in the code, initially I'm running a for loop from 0 to the size of the matrix, and I'm incrementing it. And here I am running my nested for loop from I plus 1 up to n, right? It is a similar what we have discussed here. For I equals to 0, it will be running from 1 to 3. For I equals to 1, it will be running from 2 to 3. For I equals to 2, it will be running up to 3 only, right? So we are running it from I plus 1 to n, right, to n minus 1. So similarly, we are doing it here. We are running it from j equals to I plus 1. We are initiating our j from I plus 1, and we are running it up to j is less than n, and we are incrementing j here. So here we have performed the swap using a temp. You can also do it similarly like this: swap a of I of j, comma a of j of I. It depends from language to language. Like in C++, we can do it like this. And after performing this operation, this swapping, is this for loop, we will be obtaining our transpose of the matrix. And after obtaining the transpose, what we are doing, we are running one more for loop from 0 to n, and in this for loop we are reversing our each row of the matrix, right? If we have like 4 rows, 1 2 3 4, and we will be reversing each row one by one. So after finding transpose and reversing each row, we will be having our final rotated array by 90° in clockwise direction. So as it is a void function, we have to perform operations in our original matrix. So this question is completed here. I hope you all understood this problem. Thank you for watching, everyone.